Students, in lesson 3.12, we are going to choose a method. Our essential question is, what method could you choose to find decimal sums and differences? And what you're going to want to prompt yourself to think about is the properties of addition, because those properties of addition that we learned in chapter 1 are going to loop back into our lives here for chapter 3 in this lesson. So we're going to start with the unlock the problem, real world. There's several little guidelines we have on the side that we have to make sure that we take into account. First, it says, underline the sentence that tells you what you're trying to find. Boys and girls, always look for the sentence with the question mark. That's telling us what we're trying to find. Next, circle the number that we need to use. And then finally, what operation will we need to use? And when we find that operation, we're going to write it down right here. So, let's read about the problem. At a track meet, Stephen entered the long jump. His jumps were 2 and 25 hundredths of meters, 1 and 81 hundredths of a meter, and 3 and 75 hundredths of meters. What is the total distance Stephen jumped? So boys and girls, when we hear the word total, we should think of sum. So we know that the operation that we're going to use here is addition. Next, boys and girls, we have to circle the numbers that we're going to use. So, because he made 3 jumps, we're going to circle all 3 jumps, because we'll need to add up those and find the sum of those. And then, boys and girls, lastly, it says, underline the sentence that tells you what you're trying to find. We're trying to find the total distance Stephen jumped. So, it says to find decimal sums and differences, we can use properties and mental math, or we can use pencil and paper math. At first, boys and girls, this strategy, which is the second strategy, you're going to think that that's easier. But actually, if you use properties, you're going to find out later on that the first strategy, which is properties and mental math, is going to be quite more efficient and less time consuming. So remember, you always want to work smarter, not work harder. So, boys and girls, our first way, we're going to use properties and mental math. So notice we're going to find the sum of the total jumps that he made. So right off the back, if we add them up just in the order that they had them in, we have 2 and 25 hundredths plus 1 and 81 hundredths plus 7 and 75 hundredths. Now, boys and girls, we know that the commutative property of addition says it doesn't matter if you add A plus B plus C, or if you add B plus C plus A, the sum is still going to be the same. So this is an example. Remember, I'm just using variables to show you that no matter what order the addends are in, you're still going to get the same answer. So boys and girls, what we did was we took this 3 and 75 hundredths and we added it to the front. And the reason why we're doing that is, if you notice that it looks a lot like our benchmark decimals, and these are very easy for us to add in our head. So what we're going to do next is we're going to actually put in parentheses 2 and 25 hundredths plus 3 and 75 hundredths. And what you'll notice is we've added parentheses. Associative property, boys and girls, remember again, says that you need to add up everything in parentheses first, and then you can go on adding the rest of the terms. Again, the reason why we use the associative property, which asked us to group the first 2 numbers, is that they contain the benchmark decimals, 25 hundredths and 75 hundredths, which are really easy for us to add in our head mentally because it's thinking about money. So if we add those 2 amounts together, boys and girls, we get 6. And now we can pretty easily in our head add 6 plus 1 and 81 hundredths, and we get 7 and 81 hundredths. So this is the first strategy. Remember, we're using mental math and properties. Now we're going to move on to the second strategy, which is pencil and paper math, which you might like a little bit better at first, but as time goes on, you'll start to realize that it's quicker and more efficient to use properties and mental math. So we can use place value in this strategy. So what we're going to do is we're going to do 5 plus 1 plus 5, and we get 11, so we need to regroup over the tens place. Next, we're going to do 8 plus 2 is 10, plus 7 is 17, plus the regroup 1 is 18, and we're going to regroup. Make sure we bring down the decimal point. 2 plus 3 is 5, plus 1 is 6, plus the regroup 1 is 7. So the total distance that Stephen jumped was 7 and 81 hundredths meters. Now, boys and girls, you notice the answer is the same in both of these strategies. It just, both strategies are what you're going to need to know when you have to demonstrate your ability to solve these problems. Now, boys and girls, we're going to try one more problem. We're going to do this, try this activity with each other. So, it says, in 1924, William DeHart Hubbard won a gold medal with a long jump of 7 and 44 hundredths meters. In 2000, Roman Chernikov won the bronze medal with a jump of 8 and 31 hundredths meters. How much longer was Chernikov's jump than Hubbard's? So what we're going to do, boys and girls, is we're going to do two different strategies. We're going to use place value, and in place value, we have to line up the numbers. Notice, the jump that was longer had to go first, and the jump that was shorter had to go second. Remember, order matters. You can't change around the order in a subtraction problem. The order matters. So right off the back, if we look at this, we can't do 1 minus 4, so we're going to have to regroup. We go to the tens column. We can't do 3 minus 4, so we have to regroup, and we have to go to the ones place. So we're going to take a 1, and we're going to take 10, and then we have 13. And then what we can do is we can take 1 from here, and we get 12, and we regroup, and we get 11. So now if we have 11 minus 4, we get 7, and 12 minus 4, we get 8. 7 minus 7 is 0. So our answer is 78 hundredths. Mind you, we just use our strategy of using place value to solve the problem. Another strategy is we can use a calculator. So what we would do is we would punch in the first number, and we would subtract it by the second number, and in our calculator, we would get the answer of 87 hundredths. So Chernikov's jump was 87 hundredths meter longer than Hubbard's. It says, explain why you cannot use the commutative property or the associative property to find the difference between two decimals. Now remember, the commutative property of addition says it doesn't matter which way you add the terms, the sum will be the same. So if we plugged in the answer here, we said 10 plus 2 or 2 plus 10. Are we going to get 12 in both cases? Yes. So this would be an example of the commutative property. However, in boys and girls, in subtraction, if we do 10 minus 2, we would get 8. If we say 2 minus 10, we know that we don't have enough there, and we would actually get a negative integer. So one reason is that you cannot change the order of the terms that you subtract. Okay? Also, let's think about the associative property. Associative property says it doesn't matter how you group the different terms, and I'm going to put down associative on the side. Your answer will still be the same. So what if we do is we plug in some numbers here, boys and girls. We can see 2 plus 5 plus 2, or 2 plus 5 is 7. 7 plus 2 is 9. Now, boys and girls, if we do this over here on the other side, 2 plus 5 plus 2, 5 plus 2 is 7. 2 plus 7 is 9. It doesn't matter where we change the order of the terms, our sum is still correct and it's still the same. Now, boys and girls, if we use subtraction for that, however, we'll notice that our answer is not the same. So what I'm going to do is I'm going to write down here that my answer is when you subtract, if you change the order of the terms or you group the numbers in a different way, the answer changes. and that doesn't happen in addition. However, if you change the order of the terms or you group the terms differently in a subtraction problem, it would change the answer.